This video goes with handout 3. In this one we're going to start by looking at a pattern. We are able to always, if we want, get the negation of P and Q if we have in our hand not P, or if we have not Q. Here's a very simple example where this is used. How would you get negation of A and D from not A? Make a disjunction, which you are allowed to do with the negation of D. So from not A, the negation from not A, the disjunction not A or not D follows. Obviously the conjunction would not follow, but the disjunction does, and that's the rule called redundancy. Redundancy. This sounds like a really stupid rule. On its own it makes little sense. Why would you need it, you think? But it's exactly for this kind of strategic result that you would use the redundancy rule. When you have the negation of A, disjunction negation of D, you are then able to make the negation of A and D, infer this from premise 2 here by De Morgan's. In the next example, we're going to do something similar. We're going to work with these premises A, then D and E. Second premise, not D. And the conclusion we want is not A. How do we work with these? Notice that we have a way to set up for modus tollens here. And in order to be able to do modus tollens here, I need to have on hand the negation of D and E. And that I can get just the way I showed you a minute ago. Make a disjunction of not D with not E to redundancy. Excuse me, this is not called redundancy, this is called addition. Let me fix this. The rule is right, except I had the wrong name down. Now we are able to write the negation of D and E based on 3 with De Morgan's. And this is something I did because I wanted to get not A using 1 and 2 modus tollens. Okay, now next we can notice that there's a commonality. There's a rule that we are already actually familiar with, known as the contraposition rule. Now, the contraposition rule would be familiar to you because when we were discussing how to symbolize only if sentences, we noticed that if P then Q is equivalent to if not Q then not P. We can turn this into an equivalence, and it allows us to handle certain derivations. In this example, we are going to use the contraposition rule. Now notice that you can get the desired result here by using hypothetical syllogism, but first we have to transform the first premise to the other conditional that it is equivalent to, namely not D then not A. So 1 contrapositive gets us this. So since not D then not A and not A then C, not D, then C follows from 2, 3, hypothetical syllogism. And redundancy, the name I used incorrectly a minute ago, is also a rule, and redundancy is the rule where we have P be equivalent to P or P. Okay, and now there is an argument form that you might be familiar with, known as argument by cases. You can see this in the middle of the handout number 3, and you can notice that redundancy, by using constructive dilemma from premises 1, 2, and 3, you would get C or C, and then that would turn out to be equivalent to C using the redundancy equivalence. I just explained it down. I'm sure it's so simple you can follow it. Next, I want to work on the other one of the other arguments on this page, on this handout, and this is here's our argument. Now, as a general rule, when you have a conjunction, I would recommend that you simplify the conjunction to get the conjuncts separately onto your page. Now, so that means if we follow this advice, we get A or B from one simplification. We can also get not C from one with simplification. So it's not a bad idea to do this, even if you don't immediately see what you're going to do with these conjuncts later on. Next, what can we do? Now we have if A, then C and D. We know that A or B. Do we know any consequence of B? If we did, then we would be able to use constructive dilemma. We do know a consequence of B. We can get if B, then D from 3 with conditional exchange. Now let's put it all back together. Either A or B, says line 4. If A, then C or D. If B, then D. So 2, 4, 6. Constructive dilemma got us this result. Now, we want to infer D out of this. And D appears in a disjunction. How can we make use of what rule we just learned, the redundancy rule? Now the appearance of D twice in this disjunction is our clue. We can do the following. We can use associativity to get the following sentence from 7. Further, we know that not C, that was at line 5, so that would get us D or D from 5, 8. Disjunctive syllogism, and with redundancy we get D from D or D. 9, redundancy. In the next example, we're going to use the biconditional rule. Every biconditional is equivalent to the conjunction of two certain conditionals, and that's what the biconditional rule talks about. So the first premise here is equivalent to if A then B and if B then A. That's pretty much the definition of the biconditional. When I introduced it to you, I defined it in this way. Now, we can simplify these conjuncts from this conjunction. If B then A, from forced simplification. And we would like to get C and not D. Let's not forget that. Let's not forget what goal we're after. Further, we are able to simplify B from 3. And you probably immediately notice that 6 and 7 would give us A by modus ponens. A would give us C by 2 and 8 modus ponens. Now the question is, how do we get not D? Well, that's easy. It's in D. Not D is in premise 3. And here we go. Finally, we're able to make a conjunction of these two from 9-10 conjunction.
Made with Doodlecast Pro.